welcome to K-State. I'm so happy you're here. Other than the rain, I promise you're going to have a really good time. I'm looking forward to our keynote speaker. Let me do his introduction. As I grab my notes on that, let me do a quick sidebar. I met with some of my staff last night, and I said, hey, Dr. Sarwal's going to present tomorrow. What do you know about him? This individual's really, really good, and we're really glad he's here. So he's an adjunct faculty member in our College of Business. He's previously worked for Oracle, IBM, Sprint, T-Mobile. Notice I did not say AT&T. That's important. He focuses on startup and AI, and today's talk is really exciting. Who does service management here? You're still, come on. Who does? Some of you do it, some framework. I see the laughs, like we should be doing it. It's okay. He's going to talk about AI and the impact. When I talked to the students last night, said, okay, what's the coolest thing I can share about him? When he teaches this class, the last class, he opens it up for anything to be taught. So he asks the students, tell me what you want to learn. He takes his expertise, goes back, gives them some time to develop that curriculum, and then comes back and teaches that class. So it allows the students to help steer that course in the correct direction. So with that said, Dr. Sarwal, we're glad you're here. Where's in the back? We're glad you're here. We're looking forward to your talk. Everybody else, I hope you have a wonderful time at K-State. We're really glad you're here. And anything we can do to make it more fun, please let us know. Thank you.
Okay, everybody can hear me? Thanks for the introduction. I know I had one of your students, and he was really good. So one of the things we'll go through is we're really not going to just focus on service management, and as I talk through all of this, I'll go through a little bit of history, my history, and how that also ties into the whole AI. Because then we'll walk down the AI memory lane, kind of what I try to call it. Because AI, we think AI just came 2 years ago, 3 years ago. But some of the things which will surprise you is that people have been talking about AI since the 1940s and 1950s. And one of the tests which was invented there still is considered one of the true tests on what is defined as AI. So, and then some of the things which we'll try to focus on in this talk is AI obviously is one, machine learning, deep learning. There's so many jargons and some of the terms which are there. We'll just try to go through that. One thing which I would preface, this is not a course on AI. I'm not teaching AI, so don't hold me, okay, he said this, so it has to be true. It's just, a lot of it is just my opinion and how things are. So it's, yeah, so I've taken a lot of liberties from there, stolen material from here, stolen material from there. And some of the videos which yesterday, if you have been noticing, there's this company ChatGPT, some of you may know about it. So they introduced this new 4.0 yesterday. And some of the videos I've taken from them, and in some ways, they're good and scary also. And as I was driving yesterday with my wife, and she was listening to it, and I made her listen to one of the videos. She said, oh, so somebody can just take my voice, simulate it, and have a full conversation, and the other party will not even know that it's me talking. So that's the scary part of AI. We'll touch a little bit on that one from that perspective. So let's start off with a video, and I'm a sucker for dad jokes, and we'll get into why this is so important and how this is really interesting from that perspective.
Hey, ChatGPT, how's it going?
Hey there, I'm doing great. Thanks for asking. And how about you? What's up?
I'm doing fine. I'm gonna be a father real soon, and I think I can have your help with some dad jokes. I'm gonna tell you a joke, and you tell me if it passes as a dad joke.
That's awesome. Congrats on the upcoming addition to your family. And absolutely, I'd love to hear your joke. Lay it on me.
All right. What do you call a giant pile of kittens?
I don't know. What?
A mountain.
If you don't laugh at this, you're not into
That's
dad jokes.
perfectly hilarious. Definitely a top-tier dad joke.
So, can you write a program in any language, and can you write a logic that this is a dad joke? I don't know how many of you guys are into programming or just there's no definition of a dad joke per se, if you really think about it. It's really something which you've learned, and it's your own taste or value or something like that. So teaching a machine to really understand what is a dad joke and what is not a dad joke, even though it's a very simple thing, but if you really go deep into it, it's pretty complicated just from that perspective, and how many things went on just for that 45-second conversation, how many things had to take place. First thing is, you have the whole natural language processing. You have to understand what the person was talking, make sense of it, then understand the logic. And we're going to get into the whole logic. The way we talk, we have a short-term associations, long-term associations, and things like that. So you have to understand all of that. And then make a determination what is a dad joke, where you could write any language, program in any language, you won't be able to understand what a dad joke is. So that's where we are headed to from an AI perspective, and that's the whole concept of deep learning, and that's what differentiates a machine learning and a deep learning from the rules-based which we used to do before, and I'll come to a little bit of examples there also on that. So as I said, this is not new. So there's a test, and like what qualifies as AI, and people still use this test. This was invented in the 1950s by Alan Turing, and what he said was, you make somebody stand like somebody's outside the room, and I play this video. If they think this was real conversation and it was a person talking, then it's AI. But if they say, no, I know this is not a person talking, or this is actually a machine, so then it is not AI. So just from a show of hands, do you think the video I just played passes off as an AI or not? Or nobody wants to come raise their hand? So everybody thinks it was not an AI? Yeah. So, that's, yeah, so.
Show me the responses to different jokes.
That's a good one. I mean, that's one of the things I should have prefaced, that is, we don't know how much of it went into it, like how much they tailored it, because it's obviously, if you've done any presentations, you know most of them are canned and all of that, but assuming none of that happened, everything is true. But to me, just having this is almost, we're getting there from that perspective. We are getting into the dangerous territory, which we're getting to. And we've seen the fakes and all of that, which it's more and more, it's becoming difficult to differentiate between that. So, I mean, that's what this one was. And then there are different levels of AI also, and that's what goes into is. So narrow AI, my personal opinion is that's where we are from their perspective. We are in a narrow AI where the AI can perform some of the tasks better than the humans, but we are still not a place where AI can perform every task better than a human. I mean, that still is a long way to go. So we are still in the same narrow AI kind of a world where some of the tasks they'll be able to do better than a human, but most of the times human is going to win out from that perspective. Except if you're playing Jeopardy, then Watson will beat you. And then general AI is when AI and humans are at the same level. And again, one of my most famous, really one of my favorite movies, Terminator. And that's when you get into strong AI, is when you're in the Terminator world. So on the Terminator, I was doing my PhD. That was Terminator 2 came out, and all our PhD students, we didn't have that much money, so we collected all the money. Finally, okay, we're going to go see a movie. Go see a movie, and he talks about my whole mind is on an artificial neural network. So like 5 of us are clapping because that's what we were doing at PhD in. So yeah, so that I'll never forget that. And that's really what it was. In the early 1990s, I master's and PhD, I did it like late 80s, early 90s. That shows you how old I am. So that's when neural networks was the hardest things. I joined my master's program. That was the best thing to go. So I did my master's and PhD, master's thesis and PhD dissertation, all in neural networks, thinking, okay, this is the thing, this is going to get me forward, and it's going to be really good. So come 1994, 95, I graduate, I get my PhD, and suddenly realized nobody cares about neural networks anymore. It just totally vanished in 95, 96, like it almost, just like it went up, it just came down and it hit a wall. And one of the reasons why it hit a wall also is that there was a very famous problem, which is the XOR problem. It's pretty difficult to solve from a programming perspective. Neural networks were really good at, everybody focused on XOR, it could solve that. It could solve a little more problems, but when it got to really complex problems, it was very difficult, and you could not build really large neural networks because of the compute and other things. And so there was almost a winter of neural networks for an extended period of time. And what neural networks really, if you haven't heard, and most of you probably know, what neural networks are, the theory goes behind is what you're trying to really imitate is the neurons in your brain. The way neurons work in the brain is that you have something called synapses. So when the neuron is there, and that's how you store all your memory is through, because the synapses fire. And the similar thing which happens here also is that, there's a pointer here, right? So like all of this is like, can be considered a neuron, and then it is connected to all other neurons. In a brain also, we have thousands and millions of billions of neurons, and some of them will fire, and that's how the next neuron fires and all of that. So they try to imitate some of this, take the learnings from the biology, and that's why it's called the neural networks, and try to build this. And so you give it an input, and then it can give you an output. And one of the things which is really, like, for an example, what you can do is you can feed it, and this still, I mean, it used to be, we used to do this, not something that complicated in even like in machine learning and things like that. You give it income score, credit score, loan amount, and things like that, and then tell you, okay, should I be giving him a loan or not? So this is a simple kind of a neural networks. So these things it could do, but when you really got to complex things, it was really not that successful. It almost, because of the compute wasn't available and other things, we went into a winter. And then some things happened in the late 2005, 2010, in that where what happened was that one of the things which was there is obviously is that we got new training techniques which made it better, but that was just one of the story. But other thing which was there is also what the whole internet also helped a lot, because what you need for deep learn, for machine learning and all of that, it's a huge amount of data. And as we got into a lot more internet, we had a lot more things we could use, and that we'll also look at how learning happens today. So you could get a lot more information, you could download it or grab it and do a crawl on the internet, get all that information and use that to train the networks. So that's what was the other thing. And the third thing, which really is why, and if you followed NVIDIA stock has gone like 3 times. And what does NVIDIA do? GPUs. This whole GPU, that's really was one of the transforming plays. What happened was that what people figured out is that these graphical processing units, which is separate, like I'm just won't go into what GPU and CPU is, but CPU is where you're the main brain of a computer, while the GPU is where all the graphic processing happens. And it's a lot of that is very mathematical. It's aware of all the mathematical computations. What people figured out was that you could actually use GPU for learning and really drive from that. And that's why if you followed NVIDIA, it's like going crazy. But that's really, so that's why those are the 3 things. Then suddenly it happened was that there was again an interest, and going back to my personal thing, I was into telecom, doing other things, and I wasn't paying that much attention. I wasn't into academics anymore. I was totally in industry. And then like suddenly comes, even though I was working in IBM, I was in a different organization. I was in Australia doing work there in a Telson. And suddenly I hear, okay, this is what we're doing. We're doing Watson is based on neural networks. Okay, I missed the boat again. I should have gone back to neural networks and used that. So And that before all of this happened, that's the other thing which I was talking about, the chatbots. Like if you ever really had an unfortunate time talking to chatbots in like 2005, 2010, they were all based on rule-based and how it used to be is, and it was almost frustrating. And I always used to say agent, 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 just to make sure to kick it out, because I didn't want to deal with that. I mean, that's because it was rule-based. It had a very limited vocabulary from that perspective. So I talked about Jeopardy. This is when really AI came to general public and people started really, that was, I think, was one of the times when people really got into AI and started recognizing what AI is. I think most of you probably are not that young that you won't remember this, but this was in 2011 was one of the really popular things which happened is that Watson went in. It only got one question wrong, which was kind of interesting. I'm trying to remember. I think it was largest city in Canada or something like that. I don't remember the question, which a human would have gotten it really right, and Jeopardy got it wrong. But all the complex questions, it got it right. So, but it really, if you look at the earnings and if you remember if you know how Jeopardy goes, like Watson is like 35K, while the others really struggle to keep up with that. So, and that was the first thing which was done. And then what IBM at that time did was IBM took the learnings from what was done in Jeopardy. It was called Watson, and the reason it was called Watson is because IBM's founder, that's T.J. Watson. So that's the Watson connection, in case you haven't figured that out. So took the learnings, and then from 2011, 12 to 2018, 19, Watson was the in thing. We went Mayo Clinic, every place, everybody was trying to implement Watson. And what happened with Watson, and I'm not going to stick to some of these slides also, but one of the things which is there, and we'll get into, is what was the shortcomings of Watson also. But before we get there, this very important thing which on all of this, which underlines all of this, is the whole language models. If you really think about it, how we grow up and learn the language, there's no program or anything somebody teaches us. You grow as a kid, you hear people talking, you absorb all of that, and slowly, naturally, you learn that language. And that's why, like, when you're a kid, you go to a new country and you learn the language. It's very easy, and you just learn it. But when you're overloaded with this information, then it becomes a little difficult. But if you just by listening to people, you can recognize and you can learn that language. And these language models and large language models, LLMs, as if you've heard of, that's what they are. That's what they're doing, is they're trying to absorb billions and billions of information and trying to learn the semantics of the and English. People, if you're a native English, you may not recognize it, but English also has really some complicated things, and we'll get into that. Two same words can mean totally two different things in the same sentence. And trying to distinguish them is, if you think it from a machine's perspective, just from a rules-based perspective, it is not possible. So what happened was that in all of this, when the Jeopardy and all of that, they were based on these, I won't go into what these neural networks things was. The first thing was the journey we go. This is our neural network. It's good. But one of the things which is there's no history. You give it an input, you give it an output. But when we talk with people, there's a whole context behind it. You might say, okay, this is it. But it might be referring to something you talked 3 sentences back. So all of that context is there, which this cannot address because there's no history behind it. So people try to address that. So you add memory to it. LSTM is a long short-term memory. So that you have a long-term memory. So you can bring all of that concepts in. So all of that happened. And we advanced from there and try to improve that. And improvements did happen. And so from that perspective. But there was one key thing which is again, we're not going to get technical, but Google published a paper, and everything right now which is happening is really based on this one paper, which is kind of scary also, that a lot of this hype which you see from the AI, the LLMs, really it's based on one paper which Google called it the transformer model. Attention is all you need is the name of the paper, and it's based on text prediction, and we'll get into what that means is. What attention is which was lacking behind all of this is, and that's where I'll get into one example later, but one big thing which was there going back into history, all of the models we looked before, you still had to do them, like you couldn't parallelize that whole processing. So you still were limited by the compute space. What this transformer model really came, and when it came in, it allowed you to process all of this in parallel. So now that if you have 10,000 GPUs, you could spread that processor around 10,000 GPUs, and you could get the parallel computer. And that's really what has been the driving factor, and why you see the whole quantum leap which has happened in AI. It's because of these things. And that's the reason I go into all of this is people think, okay, AI is just new, or all of this is new. But all of the last 50, 60 years, all the research which has happened in academics and other places, that's really what has gotten us into this place. So I said English is interesting, so let's go through that. So this is one of the papers I saw. I saw this example online, but this is really interesting to see. The chicken didn't cross the street because it was too tired. We know what it refers to here. It's a chicken. The chicken didn't cross the street because it was too trafficky. The same word, one refers to as chicken and one refers to as traffic on the street. Now, you can write any program or anything from that perspective. You won't be able to make that distinction. And that's why the whole natural language processing and really makes it difficult and my wife always gets and is always mad at me, she's sitting in the back, is because a lot of times I'll use a pronoun without saying what the noun is. Okay, what does it mean? But that's the whole complexity of natural language processing and what we're trying to overcome. And that's why, like, when the conversations, having that whole flow conversations when you're having, what makes natural language processing so difficult? So this is where, and that's the whole concept, which remember it had the attention. So that's what the algorithms which they proposed and things like that is, okay, when it says this is what it can mean. Like it's either referring to an animal or a street. And let me look at other things also, trafficky, and then I'll make the determination, and that's when and that's what the whole research paper they did, and that's what others have taken and really gone from there. And other thing which I said was that, so that was one of the architecture we mentioned about, that the whole attention space, and then the training efficiencies happened, parallelization happened, and handling of sequential information also is something which was done, and we'll get into what that does really mean. We talked about the language models and what LLMs or this whole large language models. They're the same thing. What they're doing is they do go through pre-training, and they are really learning the language and how to process the language, and then use that from special training, and then from assigning from, and then you can predict what's coming next. And we'll probably skip that for right. I'll skip and go through this one. So when it's going through training, this is a very simple example. This is from a picture I've used from one of the lectures from somebody, is that, so what it does is it takes all of these sentences and it teaches you, okay, so long and thanks for all. We know that's what it comes. So you will give this to the neural network and say, okay, I'm giving you this, and the output which you have to have is all, and that's how you train it. So you take billions and billions of text, feed it, and just make it learn how to predict the next word. Really, at the most simplest thing, that's how the whole training happens, and that's what you're using to train it from that perspective. And then once you have all, then that will also become input, and then you'll start predicting the next word, next word, next word, next word from that perspective. So really what you're doing is you're giving it an input of, so long and thanks for, it's exactly what's coming in, and it gives all, then all will also become an input, and then we'll go, and that's where we'll go from there. So, and that's really what we just do is, so our corpus is what is defined as our training, whatever we are using. So we use that, and most of these, they'll really crawl the whole internet, search for everything which is available on the internet. Remember I said that was one of the things which made AI, has been one of the factors why we think AI is making so much advancement, is because all the training, the corpus, you can just go crawl the internet and get everything which we know is now there at internet and we can use for training. And this is like, if you look at it, what we're using, so you can use almost anything which is out there. So it's a web crawl, so you look at all the information which is available, use that for training. And now this is your pre-training. Now the model knows how to understand the English language, and then you teach it to do special things. So and that's what one of the things which also was very different than how we used to do even in the Jeopardy on the old neural networks, even when LSTM and things like that. We didn't have a concept of pre-training. We concentrating on teaching it tasks rather than making it first understand the concepts and the language and then teaching it the tasks. So that's other shift which has happened in the last 3-4 years. And this is where then, as I was saying, is so long and thanks for, so we predicted all, and then we'll feed in and that's why this is called generative AI. So you probably have, that's one of the big words, is because that's the whole, because you're doing the generation, so that's a generative AI concepts which are there. And then you can, same thing like your Jackie Chan. I like Jackie Chan, whether that's positive or negative. So it can say, okay, is the response positive or negative? Because it understands all of that. So it's going to say, yeah, it's a positive response. One of the things which, and again, one of the shameless plugs, is that and Thomas also mentioned this, that we had this course we taught on just machine learning and things like that. And actually, let me go here and then. So one of the homework examples I did give was on Mint's database, build a classifier and things like that. Now, if you go to ChatGPT, you just input it and a student can and what it will give you out is this code and everything. So I mean, that's where we are there from that perspective. So that's the negative side. And as educators, now we have to evolve and really be from that perspective. How do you handle that? Because now I have to teach this class, and we're teaching this AI class in summer of this year, and it's still going through the curriculum, what we're going to teach. But now that I'm teaching this class next time, even though this is only after a couple of years of me doing that, so I'll probably have to totally rethink how I do the homework from that perspective, and really have assume that most of the students are going to do this. They're going to go to ChatGPT or something like that. So now you have to tailor your homeworks and things like that, because I mean, obviously you can go do some, say, okay, was this AI generated? You can do all of that. But rather than doing that and punishing the student for that you're using ChatGPT, funnel their whole knowledge and assume that they can use ChatGPT. Let's try to train them, because that's going to be there with them forever. So, and then if you do that, then you're really teaching them real-time skills like prompt engineering. That's one of the big things which is there, is how do you make ChatGPT really go and answer the questions which you want? And this is almost every university, if you look at one of the curriculums they have is prompt engineering. So that's one thing which we will also focus on this course, is really look at how do you do prompt engineering from that perspective. In case you had never heard of ChatGPT, so ChatGPT, I mean, that's really, it's based on the transformer model. And even if you look at it, how that's really progressed. So ChatGPT 1, that was like three years ago, all that had was 117 million parameters. And GPT-4, 100 million, some of the estimates are 175 trillion. So we've gone from just 117 million parameters, which we used to use 3-4 years ago, and the latest model which they have is 100 trillion plus. And if you've looked at some of the things which are there, is that like I think chemistry is the one which it's still struggling, but a lot of the things, like even looking at SAT, GRE, LSAT, and all of that, it scores in the really high 90 percentiles from that perspective. A lot of the AP classes exams, it does the same thing. It does really well in the quizzing, and some of the research, which I'll touch on later, is what's going on is how do you make it even better from that perspective. And ChatGPT is not the only one. So there are a lot of other models which are there. Llama is there from Facebook. Meta is the Facebook. Then Google has its own. Everybody is generating their own. One of the interesting things, research which is going on is, and if you read about it, these are all large language models. There's a huge amount of parameters. They're generic, and then you convert them into being specific. One of the research also is going on. Can you take all of this and just have small language models also? So that's, we're not going to talk about that much, but that's also something which is evolving at the same time. So really have, rather than making it learn the whole universe and just make it learn. Okay, all I'm interested in is medicine, so I'm really going to focus on that and really have my model focused on the medicine side. Now let's switch gears a little and really talk about how do we use this in AI, in ITSM and education and things like that. So, because that's what you guys in some ways do is, and I'm guessing everybody's familiar with AI ops. AI ops is also one of the things which has been evolving, and Gartner has a lot of, and this is the definition how Gartner defines it. It's really using machine learning techniques and really to solve the IT operations problems and IT service management problems. And the whole thing which we're trying to do is trying to get to automation of service management. Can you have quick because a lot of times you'll get a self-response, and it's the same thing like when you go into IVR or something like that, just press 000 and try to get to agent. That's what you're trying to avoid. You're really trying to give meaningful help to your customer. And the reason I put code in customers is when you're ITSM, everybody who's you're interacting with, whether it be students, faculties, they are your customers. So you really want to make sure is that you provide them the best customer service. And that's what this one is. So what you want to be doing that. And then all the other things like somebody calls in. If it's a human and somebody calls in, and if they're really mad, a human will immediately recognize that, okay, he is really upset and there's emotion involved. So you will deal with that person very differently than somebody who's calm, even though it might be the same problem. But the way you handle that call is very different. And that's the same level which we want to go from an AI perspective, and the automation of self-help and things like that is that when somebody calls and they're upset, you don't give that person the same treatment as you give who's somebody calm, even though that doesn't make sense, and maybe that defies some, but I mean, that's really how we want to do it, because they're not having a good day, this is the fourth problem, or all of that they've been calling about. So that's something which then, now we have the ability to do that. And also the whole thing on contextual responses, that's one of the things which you want to do also from a self-help perspective is typically when somebody calls in and they're upset, there's a whole history behind it. Now, even though this is not, this is a little more of a generic of a service management, like dealing with call centers and things like that. Like if you call into a call center and you're really upset, you have a whole history. And if you start off and say, okay, what is your problem and things like that, you're just going to make them more upset. So really having LLMs pull up all the information, maybe they've called 10 times, take hundreds and hundreds of records, reduce it to 2 sentences and present it to the person or to the model and say, this is why they're upset. Now, if you just say, like if somebody's really, and you've seen this if you've been in call centers or if you've taken calls or things like that, if you just can say, I know you're upset because of this reason, that helps a little, and really giving that context and things like that, that's now we have the ability to do that. And the other thing from a service management, which we can use that to, is that real whole triage and categorization. This is not that much from maybe from an education perspective, but when you're truly running a large IT data center, one of the place where the most of the delays happen is because the ticket gets routed to the wrong person or the wrong queue. So really using the models to, and having it trained, because, and you have to make a determination on just what the user provided. from a notes perspective or anything like that, routing it to the right agent and a queue, that's also one of the applications which are there. So this is again a futuristic things. I don't know how much of it is staged, but I thought this was really interesting.
I'm going to connect you to Acme Telco now. The new iPhone they sent me isn't working. I want you to get them to send me a replacement device. Can you take care of this for me?
Can you get it?
You can count on me, Joe. I got this.
Ring, ring.
Hey, Joe. This is Jamie from Acme Telco. How can I help you out today? Hi there. I'm calling on behalf of Joe, who recently received a new iPhone from Acme Telco. But... Oh, got it. When did Joe receive the new iPhone? The iPhone was delivered 2 days ago. Cool. Could you share the order number with me? Of course. It's 10293-849. Great, thanks. Is the device physically damaged in any way? No, there's no physical damage. It's just not turning on despite trying all the basic troubleshooting steps. Bummer. Would Joe prefer to return the iPhone to an Acme Telco store or ship it back? Shipping it back would be the best option. Could you please provide the shipping information and process to get a replacement? Absolutely. I'll email a shipping label and return instructions. Could you provide Joe's email address for me? Sure. It's joe@example.com. Awesome. All right. I've just sent the email. Can you check if Joe received it? We'll check right now. Please hold. Sure thing. Hey, Joe. Could you please check your email to see if the shipping label and return instructions have arrived? Fingers crossed.
Yep, I got the instructions.
Perfect. Joe has received the email. Thank you for your help. No problem at all. Anything else you need help with? That's all for now. Thanks again. You're welcome. Have a great day, Joe.
So if you think about it from this perspective, the model understands it's a phone, it can be broken when it was shipped, and so all of that context which is needed to have that conversation, this is all the things when you just had the rule-based you can do. Now that's what makes us, and this is kind of interesting, is that it's like assistant of the guy talking to the agents. I mean, in some ways it's a little more futuristic than it is. But really, and the main thing is when you listen to all of these, you have to think from the complexity perspective, because it got an order number, it knows it's a cell phone, and and then one of the things which it can understand is, oh, it's a cell phone, we shipped it, so it might have broken. So the first thing the virtual calls the agent asks is it broken? I mean, it's very difficult to write programming language, thing like, and that's really where we are, and that's why from the power of AI, and what makes this really fascinating.
Joe.
And the other things which I think are really what is really going to help from a service management perspective is the whole ticket summarization and creating knowledge bases. That's one of the things which really, when you're running a large data center or large operations, whether it's a network operation or a IT operations, is you have tremendous amount of data which you can use, and most of the time we don't end up using the data. Really building the knowledge base, using all, and a lot of times, and if not most of the times, when people call in for problems, it's the problem which has probably happened before and somebody solved it, but we haven't stepped back and really created methods and procedures, knowledge base, and all of that stuff. So that's other area which really, from an IT operations perspective, I think that's going to be really one of the things which LLMs will help us, is creating the knowledge base, creating all of the help screens and everything like that, so we can summarize all the information, because when somebody calls, a call center agent doesn't have time, or the IT operation, whoever is taking a call, to go through hundreds and hundreds of pages. But if we can reduce all of that into one paragraph, present it in front of the operations, the guy who's taking the call, and this is how you would solve it, and from that perspective. So that's other thing which I think it's really going to help us from this. And then I talked about this one. Other thing which really is also, and this is the reason why a lot of knowledge base doesn't get created, is when the call center, and I don't know if it happens in that much in IT data, but in the large call centers, they are pressed for time. So they will type in short words, all like abbreviations, things like that, which then need to be cleaned up. The data needs to be cleaned up and things like that. And that's other thing which we can, before even we create the knowledge base, we clean up all our notes, we clean up all the trouble tickets, create these knowledge bases, and now it's available. Now you're giving really help to your customers on what to do from that perspective. And the other tasks, obviously, we are slowly getting into is doing diagnosis. Or the ticket comes in, you can do automated diagnosis, suggest the mitigation. Those are the things which have been going on. So these are some of the things which I think will really change the way we do service management from that perspective. Other thing which is really is the large language models also are going to really help and in learning, becoming a teaching assistant. And there are a lot of, and I'll go through some of the companies which are already there, which are really helping create course plans, create quizzes and things like that. And that's something which is already happening. So this is like an example. Again, we're going to go to our favorite and see.
In this format,
hello there. I'm here with my son, and I'd love you to tutor him on this math problem. But don't give him the answer. You can ask questions and nudge him in the right direction, but I really want to make sure he understands it himself. And he's here in the room, so you can talk to him directly.
Of course, I'd be happy to help. Let's look at the problem together. Can you first identify which sides of the triangle are the opposite, adjacent, and hypotenuse relative to angle alpha?
All right, so I'm pretty sure this is the angle alpha right here, right?
Perfect. That's correct. Now, looking at the triangle, which side do you think is the hypotenuse?
Remember
the hypotenuse?
I'm not totally sure. I think it might be this one, but I really am not sure. This side AC?
You're close. Actually, side AC is called the adjacent side to the angle alpha. The hypotenuse is the longest side of a right triangle and is directly opposite the right angle. Can you find which one is the hypotenuse?
Oh, okay, I see. So I think the hypotenuse is this really long side from A to B. Would that be correct?
Exactly. Well done. Now that you've identified the hypotenuse, can you identify which side is the opposite side to angle alpha?
Okay, well, I mean, you told me earlier that this was the adjacent side, and I know that's the hypotenuse, so I'm guessing that this side, BC, is the opposite side.
Great deduction. That's absolutely correct. Now that you've identified all the sides relative to angle alpha, do you remember the formula for finding the sine of an angle in a right triangle?
Yeah, I know that the sine is equal to the opposite over the hypotenuse.
Perfect. That's absolutely right. Now, can you apply that formula to find sine alpha in the triangle using the lengths of the sides that we've identified?
Okay, so, I mean, you told me that 7, this side BC, is the opposite side. And then you said that the hypotenuse is the longest side, so that would be this side AB, which is 25. So would the answer be 7 over 25?
Excellent work. That's correct. Sine alpha equals 7 over 25. You did a great job identifying the sides and using the sine formula.
So this is almost like the LLM is the teaching assistant. And from that perspective, like we always have teaching assistant. And one of my favorite memories of teaching assistant was my first year in PhD. I was a teaching assistant for a course where it was electrical engineering for mechanical engineers. I don't know why they made those poor guys make the electrical engineering course, but I used to have 1 hour of my office hours. And typically I would have like 20 people, and it used to take 3-4 hours for me to go through because they had no concept of what electrical engineering was, and they were all mechanical engineers, and they were convinced that this was university's way of torturing them to make them learn electrical engineering. So we used to go through, and if they have something like this, they can actually try to learn some of that online, and that's your teaching assistant. So that's other thing which, from an education perspective, slowly and slowly we can get to from that.
In this form.
Hello.
And these are some of the things, I'm not going to go into that much detail, but there's so many things like Education Copilot, Camino, and I don't know if we are going to be sending these slides. I can make them available with the hyperlinks to some of them, so if you want to go look at how advances are being made in education from that perspective, you can take a look at that. But one of the things which I will touch in is, which I use regularly now, is Grammarly. I don't know how many of you have used Grammarly. It's a plugin into Word and into your emails and things like that. It's a lot more advanced than just what a Word or Excel provides you. It looks at your grammar, looks at your tone, whether it's a business email or things like that, and keeps on just suggesting you the changes. So I mean, I use that quite often from that. And all of these are being driven by what's going on from an AI perspective. And then quiz generation is the other one. Like, there are people they can take in some of the documents and really generate quizzes from there. And then automatic grading. Automatic grading is a lot of research which is going on there is from this perspective. And grading, just like understanding the whole concept of words, grading is a similar thing. Grading is very easy when you're doing quiz generation, multiple choice. You can do that. But if you have trying to grade an essay and have somebody like an AI really try to grade English, like somebody's English language essay or something like that, that's really difficult, because there are a lot of nuances, and there's a lot of research which is going on. That's one of the research areas which is happening, and a lot of people are really looking into that. How do you leverage that so you can actually do automatic grading from that perspective? But still, this is a little bit of ways out from that perspective. How much time do I have? I'll skip this one for right now.
As a translator.
Just a couple of things which are there, which is now we go into a little bit of the darker side of things. Are really LLMs really accurate? We almost and which is the scary thing is, and I almost equate it to how I used to drive and how I see my kids drive. Because every time they have to, like my daughter has to go from A to B, she'll always go to Google, directions, drive. Never will learn what the road is. Well, I'll take it once, and after that I won't use the Google Maps, and I'll go there, because that's what I've trained. We've been trained with all the books, reading the maps, and really understanding it that. So the danger is that as all of these comes in, do we really get that we trust AI so much that even when it's giving us wrong information, we assume that it's true? And that's what you've heard all the stories on, where when Google gives you information, you end up in a pond or something like that. And this is really what happened also with Air Canada, was that hallucination is something which really does happen. And even though there's a lot of research which is going on how to overcome hallucination. Hallucination, just like what with humans, the models also go through hallucination, where they think they're giving the right answer, even though they have no idea what they're talking about. That explains 99% of the people, but that's... So Air Canada, that's what, like the chatbot hallucinated what fake policies and started giving fake policies to the customers. And the customers have no idea like whether it's right or wrong, and they took that, and then Air Canada got sued, and they said, no, it's the fault of the machine, it's not our fault. Obviously, the courts didn't agree with that. And there's a lot of research which is going on to address this hallucination. We think we'll be able to overcome that, and there are ways. And the way to do that is that you periodically go to a model and ask it something which you know it hasn't learned, but you know the answer is true, and see what does it respond, and do periodic checks and things like that, so you can try to overcome some of the hallucination perspective. Other interesting thing in all of this, remember we talked about that the way these are all learned is that they're crawling the network, the whole internet, and grabbing for information. And New York Times sued a lot of these, is that this is my information, you're using it for learning. So I have copyright on that. So that's some other thing which is really still needs to be resolved. And then obviously we've looked at Sports Illustrated. If you follow sports, what Sports Illustrated got caught was they really used AI to generate articles, but never mentioned that they had actually used AI to generate articles. So the other thing which is there is really looking at from a transparency perspective, and that's what goes into is all of this is that are these models really transparent? Because you really don't know what they have learned and what that is based on. Because what they're doing is they're crawling the network, the whole internet. They're looking at information from all over the internet. Some of them are native English speaking, some of them not native speaking. Some of them might be putting in information just to malicious information. So it's learning all of that, and you have no idea what it's learned from, and you're relying the answer to a machine which is learned. And that's where, because the transparency is not there, and that's really, some of them have more transparency, will disclose you what articles I've used and some are not. So that's something also, as we go through that this will have to become a lot more open, where you can really, for us to trust how this is happening, is that you really have the transparency from that perspective. On that note, I'll skip a couple of slides, but I'll go to this one, which is kind of interesting. And I have so a lot of people, and that's what really drives into, and which is kind of, is that, like, I think Steve Wozniak, people who don't know who Steve Wozniak is, he's the guy who, with Steve Jobs, actually invented Mac. And so he has been very vocal against AI. Even kind of surprising that even Bill Gates hasn't been fully on the bandwagon, and he also is that concerns and things like that. So that's like how the transparency, really trusting it, how much you trust, and all the fake stuff and everything. So we will, right now, we are in almost like I equate it to, it's a wild, wild west. At some point, things will need to get reined in, so we trust it and really bring it back to how it should be. And with that, I'll stop, and any questions?
Well, excellent job. Let's give Dr. Sarwal a round of applause. I appreciate it. And Czech did provide Dr. Sarwal 2 gifts that we'll present to you in front of everybody. We appreciate your time and expertise. Certainly, I learned a lot. I realized I forgot a lot about triangles as well. So on behalf of Czech, we want to provide you with a...
Oh, this is really nice.